Hey guys, so this week we're going to talk about zeros, or the factors of polynomials. And so what are different names for zeros? Well, sometimes we call them factors, or we call them roots, or we can also call them x-intercepts because it's where they cross the x-axis. So for a polynomial degree n, so if the degree is any number n, then the function is going to have at most n real roots. So it can have as many real roots as it has degrees. So if the degree is 10, then it could have up to 10 roots. If the degree is 5, it could have up to 5 roots. In this example here, we have a degree 6 polynomial, so this could have a maximum of 6 real roots. In this example here, we have a degree of 3, so this could have a maximum of 3 real roots. Okay, how do you find the zeros for a polynomial in factored form? Well, this is just zero product property, just like you learned for quadratics. So we're going to use zero product property by setting each factor equal to 0 and solving. So in this case, we're going to take, basically we're saying y, or f of x, is going to equal 0. So then we have to take each of these factors here. If any of them equal 0, the whole thing will equal 0, so we can set each one of them equal to 0 and solve. So either, oops, that's not what I meant to do, either 2x plus 1 equals 0, which would make this negative 1/2, subtract 1, divide by 2, negative 1/2 there, or x plus 2 equals 0, so x equals negative 2, or x minus 7 equals 0, so x equals 7. So those would be the values of your 3 roots. Okay, in this example B, 3 doesn't matter, it's just our multiplier, it's just the a value, so it doesn't change where the roots are, it just changes the stretch or compression, stretch in this case, and this thing's going to face upside down. But for solving for the roots, we do the same thing. X minus 4 equals 0, so x equals 4, or 5x plus 1 equals 0, so x equals negative 1/5 when we solve for x, giving us those 2 roots for that quadratic. Okay, same principle applies down here. Give these a try yourself and then check the answer in the Edpuzzle and make sure you got them correct. Remember, double roots, they count as 2, but there's only one answer to that. And then if you have just x by itself, that's going to be 0, because if you set each term equal to 0, then x would just be equal to 0. Okay, so when we're doing equations from a graph, we're going to use the zeros to find the factors of the polynomial so that we can write the equation of the polynomial in factored form. So we're going to use the roots, or the zeros, or the x-intercepts to find the factors and write it in factored form. So what are the roots here? Well, we have negative 5, negative 3, and 4. So negative 5, 0, negative 3, 0, and 4, 0 are my roots. So to convert those to factored form, we're basically doing the inverse of what we just did, and we're bringing it back. So we'd say x equals negative 5. So to bring it back over to write it as a factor, we'd add 5 to both sides, and we get x plus 5. Same model, we get x plus 3 and x minus 4. Again, just setting x equal to what it's equal to, and then bringing that value back over to the other side to join the x. Okay. Is this a value positive or negative? Okay, so let's look at the end behavior. On the left, we're rising to infinity, so my y values are rising to infinity. On the right, my y values are falling to negative infinity. When my y values fall to negative infinity, that means we have a negative a value. So this has a negative a value. So an approximate equation not solving for a would be f of x equals negative, we don't know what a is, we're going to solve for that next week, so we're just going to leave it as a negative for now, x plus 5, x plus 3, and x minus 4. And that's how we do that. Okay, so here the key to remember is that this is a bounce point, so that's a double root. So this is -7 with a multiplicity of 2. So it happens twice. It counts as a double. So you'll see people saying it has a multiplicity of 2. And then we also have -3, 0. Of course, this has a 0 too because it's a point on the axis. And then we have the point +6, 0. Okay, a value is going to be positive because both arms are going toward positive infinity. So this has a positive a value. So then we'd have f of x or y equals x plus 7, taking my factor there and creating, or taking my root and creating a factor. And then we square it because it has a multiplicity of 2. It's a bounce point there. And then x plus 3 and x minus 6. Again, just like we did with quadratics, only we have more this time. Okay, give this one a try and check your Edpuzzle notes. Big hint here, this guy is a multiplicity of 3 because it looks like a little cubic function. If you just look at this part here that I've outlined, it looks like a cubic function, so that has a multiplicity of 3. So keep that in mind when you write your equation for that. And then again, check it in your Edpuzzle notes. Hope you guys are doing well. Miss you.